So while performing operations and maintenance work, you may have to isolate an individual source circuit of the system. So we're going to go over now how to safely perform that operation. First off, you want to make sure you have your proper PPE on based on the fault hazard that's available. You also want to consider that the system, if it's turned on like it is here, is under load. So there's going to be current flowing in all of those circuits. To safely lift a fuse holder, we want to be sure that there is no current flow. So to do that, we're going to turn the system off. So now that we have our system turned off, we still want to confirm that there's no current flow because you might have a fault of some kind that we don't know about. So the big difference between what you see here and a circuit breaker is that these are touch-safe fuse holders. They're not actually load break rated like a circuit breaker is. So if I go ahead and I open this thing up under load, it can have a really dangerous arc there that could set this box on fire and hurt whoever's working on it. So I want to be sure that I identify this as a touch-safe fuse holder, and I know that I need to confirm and double-check that there's no current flowing in the system. I'm going to use my clamp-on meter to verify that there's no current flowing in the system. Now, the typical meter you might find in your hardware store might only be rated for AC. This one right here is rated for AC and DC. So you want to make sure you have the right clamp-on meter since we're testing DC. I'm going to set it to amps. And I'm going to zero out the meter and make sure it's on DC. So I verified that there's no current flowing in the system. Safely lift my fuse holders, and now I've isolated each circuit in the system.